Hi, welcome back. If you haven't checked out the proof for the sine rule, go back and watch that. We're going to be doing in this video the proof of the cosine rule. Again, I've started by drawing myself a triangle and color coding it. That's not necessary, but you know. And putting side A opposite angle A, angle B, and side B opposite each other, etc. Now, I'm required to prove that a squared is equal to b squared plus c squared minus 2bc cos a. That's the cosine rule. The first step is quite similar to the sine rule in the sense that we're going to run a perpendicular here, perpendicular to b. And I'm going to call that h. So I'm going to split this into two triangles. One here and one here. Now we know that side B goes from here to here, but where side H hits B, I'm going to call this X, and it would logically make sense, right, that if the whole thing is B and this is X, that this little bit here needs to be whatever B is, take away X. So that one's going to be here, B take away X. So I'm going to start on the left triangle here, and I'm going to use Pythagoras' theorem to make a formula for a squared because I'm trying to find a squared. Now remember what we said before, that if the 90-degree angle is here, the right angle is there, h is opposite. So Pythagoras' theorem states that h squared is equal to a squared plus b squared. So don't get this a mixed up with the A in the diagram. So in this diagram here, the hypotenuse is A because it's opposite the right angle. So we've got A squared is equal to, we would have A squared plus B squared. So we can multiply that out by opening up the brackets. So that would give me a squared equals b squared minus 2bx plus x squared plus h squared. I've rearranged it a little bit because I can already see that it's starting to take shape. So I've got here a squared equals b squared plus c squared minus 2bx cos a. So I've put the b squared here, so it's matching up, and minus 2b, so I need to find x. So what I'm going to do now is I'm going to work with the smaller triangle here. I'm going to start by trying to get a formula for x, because if I've got a formula for x, I can replace the x here. So if I look at the little triangle here, I know that x is, if this is going to be the height, so this one here would be the height opposite the right angle. This one here, h would be the OPP, the opposite, and the last one left is adjacent, right? So in this situation, I would say cos of the angle, I'm going to move this over the side here. So again, I'm working in triangle 2 now. I'm working over here. I would say cos of the angle is equal to adjacent divided by height. So in the green triangle, the angle is A, so cos A is equal to adjacent, so that's the opposite, this is the adjacent. So x divided by, and the height is c. So I want to find x, I want x to be the subject of my equation because I want to substitute it in here. So I can move my divide by c to the left hand side and say c times by cos A is equal to x. Now that I'm going to substitute in here. So now my formula is looking a little bit closer to what is required, because let's put it in here. So I'm going to replace x with c cos A. So now that part here is matching up. Whenever I do proofs, it's really good to keep in your mind where you want to go. What does your final answer need to look like? Because then you can start moving your maths towards that. Now, we can see that we're also missing the c squared, right? That our final answer was in terms of a squared was in terms of b and c. There was no h, there was no x in the answer. That's why we solved for x here, so we could remove it, okay? We need to do the same thing for x squared plus h squared. So still working in the green triangle, in triangle 2, I'm going to form an expression for x squared plus h squared. And we already know that it needs to be c squared, right? Because we know what the proof, we know what the formula is, what the answer should be. So if I'm trying to get a formula that links x squared and h squared and c squared together, and I've got a right angle triangle, it makes sense to use Pythagoras' theorem. So you know that Pythagoras' theorem is hype squared is equal to a squared plus b squared. So in this case, the hype would be c. So it would be c squared is equal to h squared plus x squared. So I can take that and directly replace the h squared plus x squared with the c squared. So I'm going to put it in red. And then you're finished. So to recap, you take a triangle and you split it into two. You form an equation with the left triangle because that starts you out getting a squared, which is what you're looking for. However, that answer in there has x squared and h squared and also an x. You work on your left triangle first of all, or secondly, it doesn't matter the order, to form an expression for x using ka, cos is equal to adjacent over hype. And secondly, you do Pythagoras' theorem because that gives you a formula that links together h squared and x squared with c squared, which means you can get the last part of the puzzle. If you would like to look at the more beautiful, neat, tidy, color-coded notes, check the links below in the description. I'm going to be doing some videos today also showing you the practical applications of cosine rule. How can you use it with numbers? What information do you need? So make sure you check those out too. Bye for now.